All right, so we're going to do the first 5 of the multiple choice pack from 1998. We printed them. Hopefully you got them. You can work them each. And each of these questions, in my opinion, the first 5 are about a minute each, max. What is the coordinate of the point of inflection of the graph of this function? First of all, we realize the second derivative tells us that. So without much thought, you got to go to the second derivative. 3 times a third is 1, so x squared plus 10x. And the second derivative is 2x plus 10. Everybody, here's the thing. It doesn't say that there is no point of inflection. We should be able to picture that the line graph, we should be able to picture 2x plus 10 like this, right? Does everybody agree? It's pretty obvious it's negative and then goes to positive. So the answer to number 1 is D. Because that's the 0, but that's where the sign change occurs. Number 2. It's right there. Number 2, the graph of a piecewise linear function is shown. What is the value of the integral from -1 to 4 f of x dx? So it's asking you to find the area under the curve for that shape and that shape. Realizing the red one is positive and the blue one is negative. It's a trapezoid. So if I'm doing this on my test, I would catch that this is 3, this is 1, this is too tall. 3 plus 1 is 4, divided by 2 is 2, 2 times 2, the area of this is positive 4. The blue one is 2 by 1 by 1. So 2 plus 1 over 2 times 1. So it's -3/2. So there must be a 5/2 or a 2.5. Letter B is the answer. All right. Yeah, if you're more of a triangle man, it works out the same. With rectangles and triangles, it would work out the same, okay? It's whatever's fastest if you're working the AP. I'll pause one more time here on problem 3. I lied. I'll pause on 3 for a second, and then we'll do 3, 4, 5 right back to back. All right. This would be not the way to do it, okay? But I just did a quick approximation. I actually graphed the curve in green there, 1 over x squared from 1 to 2. And everybody, based on this, I can see that the area under this curve is less than 1 because the black rectangle is 1 by 1, even though it should be a black square. It's 1 by 1. So I can immediately, and I know it's above the curve, so I can get rid of A, D, and I know 2 times ln 2 is more than 1. So literally, I can just knowing roughly what this looks like, I can get between 7/24 and a half. Now, this is not the way to do it, but this is what it means. The way to do this is to do the integral, all right? And if I do the integral, it's from 1 to 2 of x to the -2 power dx, add 1 to the power, right? So it's x -1 over -1 from 1 to 2. So it's -1 over x from 2 to 1. So it's -1/2 minus a -1. Oh, looky, looky. The answer is C, all right? And again, approximation, if you got really confused for some reason on your integral, it's still the area under the curve. We would have guessed half on that graph we had. All right, 4. I'll give a chance for you to read it, and then I'll answer it, and then we'll go on. All right, so this one's pretty straightforward. It says f's continuous on a closed interval, a to b, and differentiable on an open interval for a to b, which the following could be false. F prime of C equals the average rate of change. That's true because that's the mean value theorem. This is guaranteed true. This is the mean value theorem. F prime of C is 0. Guys, that is absolutely false. I could easily draw a curve that's differentiable A to B. How about this? That curve is differentiable A to B. That has no zeros. It's always increasing. So the answer's got to be B. To make sure I'm right, this is the tough part. I would read through the rest, actually. F has a minimum on A to B. F has a maximum on A to B. Guys, these are both part of the extreme value theorem. Yes, it's closed interval, so there are maximums. They can be the same. Finally, it says the integral from A to B of f of x dx exists. Sure it does, because it said it's continuous. If you can get a curve, you can find the area under it. So We know that. So mean value theorem was A, extreme value theorem was C and D, and E we knew, and that leaves that the derivative doesn't have to be 0. Okay? All right, problem 5, last one. Find the integral from 0 to x of sine t dt. All right? All right. So I had you memorize that the derivative of cosine is negative sine. And if you want to integrate, you just go the other way. Instead of memorizing 2 things, right? You could memorize the integrals. But so right away, if I see the integral of sine t dt from 0 to x, I'm looking for negative cosine. So I can throw away this one, and this one. The only question is it b or e? Now here's the problem. The derivative of b is sine x, and the derivative of e is sine x. All right, but remember, if we're doing the integral, but this time there's limits. There's limits of integration. It's plus c that gets us, and that's why the answer is going to be e. I can guarantee the answer is e. You get negative cosine x or t from 0 to t, or x. And this is what gets us, guys, negative cosine x minus a minus cosine 0. Cosine of 0 is 1. So this is 1. The answer is E. All right? You should have quickly got your choices between B and E, just by glancing at the problem. Everyone, knowing that 0, this is why you really want to, if you haven't memorized the unit circle, you should immediately recognize some of the standard tricks, right? Cosine of 0 is 1, sine of 0 is 0. And if I change these to 90, it's a 0. This is 1. If I change these to 180, negative 1, 0. If I change these to 270, 0, negative 1. Point is, those have to be pretty much in your arsenal. And you see this, and you think the antiderivative is this, you know there's going to be a 1 or a negative 1, depending on how signs work. All right, Braxton, calculus is funner than Fridays going to the beach.